We need to look at unions and intersections. This first symbol is the union symbol, and it goes along with the word or. The intersection symbol, which looks like an upside down U, usually goes, or doesn't usually, always goes with the logical word and. Now I'm going to relabel this. This is my union, this is my intersection. Anytime I see the word union, I like to, in my own head, think of the words join together. If we're talking about a wedding and it's the union of two people, that is a joining together. In intersection, I like to think of the word overlap when I'm using an intersection. The best way to understand how a union or intersection works is to deal with sets. I've got set A, which contains the numbers 1, 2, 3, set B, and set C accordingly. When I find A union B, that tells me to join sets A and B together, 1, 2, 3, as well as the 2, 3, 4. And their union is going to contain 1, 2, 3, and 4. Now, even though there was an overlap with 2 and 3, I don't list them twice. These are just the values that show up one or more times in their union. The intersection of A and B asks me to find where do they overlap, and they overlap at the numbers 2 and 3. What is the intersection of A and C? Well, 1, 2, 3, and 4, 5, 6 have nothing in common, and so this is going to be either the empty set or the null set as their union. Once we have an understanding of how these unions and intersections work, now we can move on and deal with this and inequalities. Here we have the word and, which says find the intersection. What I like to do here is draw a number line. Here's the number 2. Here's the number 3. X less than 2 is open circle, everything to the left. X less than or equal to 3 is a solid circle, everything to the left. Look at those two clues. The word and says find the intersection of these two. In other words, where do they overlap? They do not overlap the two because they're not on one graph and the other, but they overlap to the left of 2. So we are going to say that the intersection with and is the set of numbers from negative infinity up to 2, not including the 2 itself. Now let's take a look at another problem. Our key numbers are negative 4 and 1. So I will label them on a number line. X greater than negative 4 refers to an open circle, all values greater than. Greater than or equal to 1 is a solid circle to the right of it. And I have the word or, which says join these two sets together. When I join them together, I basically have everything to the right of this negative 4. So in interval notation, I'd write from negative 4 to infinity. Notice I'm not including the left endpoint because there was an open circle there, and I never use a bracket with the infinity symbol. In this third problem, the two critical numbers are 2 and 6. So let's do the same thing. X less than or equal to 6, that'll be a solid circle, shade to the left. X greater than 2, open circle, shade to the right. Now we have the word and, which is an intersection, saying where do these overlap? The answer is they overlap in the center, and I do include the right endpoint where they overlap, but not the left endpoint. So the interval will be from 2 to 6, including that right endpoint, which I designate with the squared off bracket. A few more examples. Key numbers in the next problem are negative 2 and 1. X greater than negative 2, let me do that in red. Open circle to the right. Next one, solid circle to the left. What numbers are on one graph or the other? This time we're dealing with the uniting of the two sets, the union, and basically all values are covered, so we will have all real numbers as our solution set for this fourth problem. Here we go with number 5. The key numbers are 0 and 4/5. We have less than the 0. We have greater than or equal to 4/5. Now this one says or, which says join these two together. Well, they're two separate sets. If this was an intersection, where do they overlap? The answer would be no solution. But because this is an or that says join them together, our solution will be from negative infinity up to 0, united with a bracket at 4/5 on up to infinity, which we don't ever include. Another pattern, 3 and 4 are the key numbers. Even though 4 was listed first, I need to make them in numerical order here. Greater than 4, less than or equal to 3, and says where do they overlap? What's their intersection? The answer there is none. I either use the null set symbol or I use the empty set symbol. Your choice of whether you have a favorite one of those two. For number 7, I'm going to need to clean up the second inequality first by subtracting 3 on each side. That will give me x is less than negative 5. So I really have two inequalities, one at negative 6, one at negative 5. The first one is x greater than negative 6, going to the right. The next one is open circle at negative 5, everything going to the left. This is the word or, which says find the union or join these two together. And when I join them together, all real numbers are in one set or the other. So our solution set is all real numbers. Finally, we're going to need to solve each of these inequalities. Maybe pretend there's a little wall between these two problems here. Let's begin by subtracting x on each side of this first inequality. That will give us 2x minus 2 is greater than 9. Let's then add 2 to each side. This will give us 2x is greater than 11. And dividing each side by 2, I will have x is greater than 11 halves. Notice that will stay at greater than because I divided by a positive. If we divide both sides of an inequality by a negative, that's when we change the direction of an inequality. Let's look at the second inequality. We're going to do some distribution first. This will give us 2x plus 8 minus 7 is less than or equal to 17. We can then combine some like terms on the right hand side. We will have 2x plus 1 is less than or equal to 17. We would then subtract 1 on each side. We will have 2x less than or equal to 16, and dividing each side by a positive 2 gives us x less than or equal to 8. Again, we did not change the direction of the inequality, and we have the word and between these. Now, 11 halves is about 5.5, so we know that that is to the left of 8 on the number line. And we're going to have a greater than the 11 halves and a less than or equal to the 8. And says, what is the intersection of these two sets, or where do they overlap? And the answer is they overlap between these two numbers, so our solution set in interval notation will be between 11 halves and 8, inclusive of the 8 on that right endpoint.